Hey guys, welcome back to my channel Practical Learning Assets. So in our last video, we discussed the main points or the main definitions and the main things that we need to know for the chapter polynomials. So in today's video, we would be starting with our exercises for this chapter. So before starting today's video, I would like to discuss whatever we have learned in the previous video. So the polynomials of degrees 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. The zeros of a polynomial are precisely the x coordinates of the points where the graph of y is equal to px intersects the x-axis. A quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. Then, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta is equal to minus b upon a and alpha multiplied by beta would be c upon a. If alpha, beta and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma would be equal to minus b upon a. Alpha beta plus beta gamma plus gamma alpha would be equal to c upon a, and alpha beta gamma would be equal to minus d upon a. So these were some of the points that we had discussed in our previous video in detail. So if you have not seen that video, you can click the above link and go to the video. So as I said a point today that the zeros of a polynomial are precisely the x coordinates of the point where the graph of y is equal to px intersects the axis. This is the point that we have to keep in mind when we are solving the first exercise for this chapter. So let's proceed to our first exercise. Now our first exercise is a very simple one, so I would be doing it on the book only. Now the graphs of y is equal to px are given in the figure 2.10 below. In this figure, for some polynomials p of x, find the number of zeros of p of x in each case. Now we have to keep in mind the point that I told for solving this question. Now for the first part, we can see that this line is not touching or crossing the x-axis. This graph for the polynomial will have 0 zeros. That means no zeros for this polynomial. So we will be writing 0 here. Then we have the second part. Here our line is touching the x-axis once only at this point. So we have only 1 0. Then in the third part, our line is touching the x-axis once, twice and thrice. This means the number of zeros is 3. Then in the fourth part, we have once and twice. That means number of zeros 2. Then in the fifth part, we have once, twice, thrice and 4 times. So number of zeros 4. Then our sixth and the last part, we have once, twice and thrice. See, this time it is not going like this. It is not crossing it. It is just touching it. So it would be once, twice and thrice. So number of zeros 3. Our first exercise was literally a very simple one and we have just completed it. So let's proceed to our second exercise. So our second exercise for chapter polynomials is here, and the first question is find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. Now for the first question, we need to find the zeros of the quadratic polynomial, and then we have to verify the relationship between the zeros and the coefficients. So let's first solve the question. Now our first question and our first part is x square minus 2x minus 8. So for this part, when we have to solve these type of questions, or when we have to find the zeros of any quadratic polynomial, we have this simple method to solve them, that is known as splitting the middle term. So for splitting the middle term, we have to multiply this digit with our first term. So here we have x square, that means, so here we have our variable as x square, so that means our coefficient would be 1. So 8 multiplied by 1 would be 8 only. So product would be 8 and our sum would be 2. Now whenever we have to solve these questions, just keep in mind, when we split the middle term, the product of the two digits that we get, or the two numbers or the two terms that we get, should be equal to this digit multiplied by this one, and the sum should be equal to this term or this digit, that is 2. So let's solve it. If I take the LCM of 8, I will get 2, 2 and 2, that is 2 for 3 times. So I'll get x square minus 4x. Then as we have minus 2x here, so we would take the sign of subtraction or the sign of minus with the greater term, plus 2x minus 8. If we see 4 multiplied by 2 would be 8, the product is 8, and plus minus, that would be minus, so minus 4 plus 2 would be minus 2. Okay, here we have to write the sum as minus 2. So both the conditions are being fulfilled, so that is the sign that whatever we are doing is correct. Let's move ahead. Then we have x square minus 4x plus 2x minus 8 in the brackets. Now taking out the common terms, we would have x minus 4 plus 2 taken outside, x minus 4. Now x minus 4 and x plus 2 are the factors that we have got for this polynomial, and our zeros would be x is equal to 4 and x is equal to minus 2. How we have taken out the zeros is x minus 4 is equal to 0. So x is equal to 4. For this we have x plus 2 is equal to 0. So x is equal to minus 2. This is how we have found the zeros. Now our zeros are 4 and minus 2. So as this is a quadratic polynomial, so we will have alpha and beta as the zeros. Therefore, alpha would be equal to 4 and beta would be equal to minus 2. Now we have verification. For sum of the numbers, sum of the zeros, we have 4 plus minus 2, that is 2 upon 1, and as we discussed earlier, our sum of the zeros would be equal to minus b upon a. Now if I say minus b upon a, so our b is 2, minus 2 and a is equal to 1. So it would be equal to minus 2 upon 1. So our product is 4 multiplied by minus 2, that is minus 8 is equal to c upon a, and our c is minus 8 and our a is 1. That means our verification is also correct. Now this is the way to solve these type of questions. So let's move to the second part. Our second part is 4s square minus 4s plus 1. Now splitting the middle term, we need to get our product as 4 and our sum also as 4. So 4s square minus 2s plus 1. 4s square minus 2s minus 2s minus 1. Why minus 1? Because minus is there before the entire bracket. So the signs inside the bracket will get changed. So taking 2s as common, we'll get 2s minus 1. And we do not have anything common here except 1. So 1 taking outside, we have 2s minus 1. Now 2s minus 1 and 2s minus 1 are the factors. Then s is equal to 1 upon 2 and s is equal to 1 upon 2 are the zeros. As it is a quadratic polynomial, so alpha and beta are the zeros. Then alpha is equal to 1 upon 2 and beta is equal to 1 upon 2. Now sum is equal to 1 upon 2 plus 1 upon 2, that is 1 plus 1 upon 2, 2 upon 2 and 1. This would be equal to minus b upon a. So our product is 1 upon 2 multiplied by 1 upon 2, that is 1 upon 4. So this is equal to c upon a. Hence verified. So this is how we have to solve these questions. I'll be solving one more part for your better understanding. Now our fifth part is t square minus 15. Now for t square minus 15, we would be solving it as t square minus 15 square. Then a square minus b square is equal to a minus b plus a plus b. This is the identity that would be used in this part. Solve it. Now t minus root 15, t plus root 15. Now these are the factors. So t is equal to root 15 and t is equal to minus root 15. Now as it is also quadratic polynomial, so alpha and beta are the zeros. Then we have sum as minus root 15 plus root 15. It would be equal to 0 as they will cancel. So we all know that sum is equal to minus b upon a. In this part we were not having b because this is t square minus 15. So it is a and it is ax and this is c. So we do not have b here, so it would be 0. And our product is minus root 15 multiplied by root 15, that is minus 15. It is equal to c upon a. Hence verified. Now our second question is, find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. For the first part, if I say we are given with 1 upon 4 and 1. So we are given two numbers. These are the sum and the product of a polynomial, of a quadratic polynomial. So now with the sum and the product, we need to find the polynomial, what the polynomial is. So our sum is 1 upon 4 and our product is 1. So for these questions, we will be using a formula, that is x square minus s x plus p. For every polynomial, we have a term as x square, then we have sum and x, then we have only product. So our x square will remain x square and our sum and x, that is sum 1 upon 4x plus product is 1. Now we is equal to 0. So taking 4 as the denominator, we will have 1x plus 4 is equal to 0. Taking 4 to this side, we will have 4x square minus x plus 4 as our answer. We can say that P of x is 4x square minus x plus 4. The second part is root 2 and 1 upon 3. So our sum is root 2 and product is 1 upon 3. So x square plus sx, x square minus sx plus p, x square minus root 2x plus 1 upon 3. Taking the denominator, 3x square minus 3 root 2x plus 1 is equal to 0. We can take it 0 here also. Then multiplying 3 with 0 will get 3. Then 3x square plus 3 root 2x plus 1 is equal to 0 is our answer. Then we have our third part, that is 0 and root 5. So our sum is 0 and our product is root 5. So x square minus sx plus p, x square minus sx. Now 0 multiplied by x would be 0, so no need to write anything here, plus root 5. This is our polynomial for this part. I have done 3 parts for both the questions for you to understand this chapter well. Now let's proceed to the next exercise. So our next is exercise 2.3. So for this exercise, we need to keep the division algorithm for polynomials in our mind. That is, dividend is equal to divisor multiplied by quotient plus remainder. Our first question is, divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. Okay, so our first part, we have p of x is equal to x cube plus 5x minus 3 and g of x as x square minus 2. So let's start with the division. X cube minus 3x square plus 5x minus 3, x square minus 2. Okay, as we have x cube here and x square, so we'll take x, it will become x cube, then minus 2x, we would be writing minus 2x here. So now we will change the signs, minus 3x square, then plus, it would be plus 7x minus 3. Now we have minus 3 because 3 multiplied by x square would be minus 3x square, then plus 6, then again we'll be changing the signs, 7x minus 9. Now we cannot multiply further, now we cannot divide further. So our quotient is x minus 3 and our remainder is 7x minus 9. So this is our answer. Next I'll be solving the third part, that is p of x is equal to x raised to power 4 minus 5x plus 6 and g of x is minus x square plus 2. It is given in the question as 2 minus x square. So I have written it in the simpler form as minus x square plus 2. So x raised to power 4 minus 5x plus 6 minus x square plus 2, then minus x square, because it will become 4 x raised to power 4, and then minus 2x square. Then changing the signs, we'll get, as the sign will not get changed here because we have nothing to calculate this term with. So it will remain as it is, as minus 2x square minus 5x plus 6. Then we have minus 2 minus 2x square. Then we have minus 4. Changing the signs, we'll get minus 5x plus 10. So here we have our quotient as minus x square plus minus 2 and the remainder as minus 5x plus 10. So this is our answer for this part of this first question. Now our second question is, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. Second question is the same as the first one, but in the first one they were asking us to find the remainder, and in the second question we are asked to find that whether the second polynomial is the factor of the first polynomial or not. So our first part is t square minus 3. This is our g of x. This is our factor, and t of x would be 2t raised to power 4 plus 3t cube minus 2t square minus 9t minus 12. 2t raised to power 4 plus 3t cube minus 2t square minus 9t minus 12. Then we have t square minus 3. Now 2t square and t square would be 2t raised to power 4. Then we'll be having minus 6t square. Now changing the signs, we get 3t cube plus 4t square minus 9t minus 12. Then we'll get 3t, then 3t cube, then we'll get minus 9t. Then changing the signs, these both will get cut. Then 4t square minus 12, then here plus 4, that would be 4t square minus 12. Then again changing the signs, here will get subtracted. Our remainder is 0. Therefore g of x is a factor of p of x. Now let's solve the third part. Our p of x is x raised to power 5 minus 4x cube plus x square plus 3x plus 1, and our g of x is x cube minus 3x plus 1. X raised to power 5 minus 4x cube plus x square plus 3x plus 1. Then x cube minus 3x plus 1. Now we have x square, that would be x raised to power 5 minus 3x cube plus x square. Then this would be, we'll be changing the signs. Then we have minus x cube, this will get cancelled, plus 3x plus 1. Then here we'll get minus 1, then minus x cube plus 3x minus 1. Changing the signs, these both will get cancelled, but we will have 2 as a remainder. So because we have 2 as a remainder, this means g of x is not a factor of p of x. Let's proceed to the third question. The third question is, obtain all the zeros of the polynomial given here if two of its zeros are root 5 upon 3 and minus root 5 upon 3. So our p of x is 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5. Root 5 upon 3 and minus root 5 upon 3 are the zeros. Therefore, x minus root 5 upon 3 and x plus root 5 upon 3 are the factors. Now we'll get x square minus 5 upon 3. This will be 3x square minus 5. So this will be our g of x. Now dividing our p of x with g of x, will have 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5. And here we have 3x. 2 minutes रुक जाओ. We have 3x square minus 5. So here we'll get x square, then we'll get 3x raised to power 4 minus 5x square, then changing the signs we'll get 6x cube plus 3x square minus 10x minus 5, then plus 2x we'll get 6x cube minus 10x. Now changing the signs, these both will get cancelled, then 3x square minus 5, then we'll get plus 1. So 3x square minus 5 and changing the signs, our remainder will be 0. Now as a remainder is 0, we have got our quotient as x square plus 2x plus 1. Now we have to find the other factors, so we will split the middle term. So we will be getting x square plus x plus 1, x square plus x plus 1. Here we will get x plus 1 and 1 common, x plus 1. X plus 1 and x plus 1 are the factors. Then x is equal to minus 1. X is equal to minus 1 are the zeros. Now this implies that the other two zeros of the polynomial are minus 1 and minus 1. So we will write minus 1 and minus 1 are two other zeros of p of x. Now our fourth question is, on dividing the given polynomial by g of x, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. So we have to find g of x. So we are given here p of x as x cube minus 3x square plus x plus 2. G of x is not given to us, we have to find it. Then q of x, that is our quotient, is x minus 2 and our remainder is minus 2x plus 4. So using this, dividend is equal to divisor multiplied by quotient plus remainder plus remainder. So dividend is x cube minus 3x square plus x plus 2 is equal to divisor, that is g of x multiplied by x minus 2 plus minus 2x plus 4. So we'll be getting g of x point x minus 2, and on this side we'll get x cube minus 3x square plus x plus 2 plus 2x minus 4. Solving this side first, we'll get x cube minus 3x square plus 3x minus 2 is equal to g of x point x minus 2. Now dividing it, we will get x cube minus 3x square plus 3x minus 2, x minus 2, then we get x square, x cube minus 2x square, we get minus x square plus 3x minus 2 minus x square plus 2x, then we get x minus 2, then plus 1 x minus 2, then we get 0. Therefore our g of x is equal to x square minus x plus 1. This is our answer.